In this video, we're going to be solving a projectile problem where we have an object thrown at a downward angle, and we're going to solve for the time that it's in the air and then also the delta x, its final displacement from the edge of this platform right here. Now we have an object that has an initial velocity of 10 meters per second, and it's thrown downward 25 degrees below the horizontal. Now, just like we always want to do, we want to split up the velocity into its x and y components. So we have a component going horizontally here, which we'll call Vx, and then we have a vertical component downward, which we'll call Vy. And then as usual, we want to break up everything into an x and y column. The reason we want to do that is because those columns have different types of motion. In the horizontal direction, because there's no forces going in the horizontal direction, once it's released, it's going to be moving at a constant velocity. And then in the vertical direction, because the force of gravity is acting in the vertical direction, we're going to use all the accelerated motion ideas and formulas. Okay, so what we're going to do is go ahead and find the Vx and Vy, because the Vx is adjacent to this 25-degree angle, and we want to use the hypotenuse. We're going to go ahead and use cosine to find the Vx. So it's going to be Vx equals 10 times the cosine of 25 degrees. And then that's going to give us a horizontal velocity of 9.06 meters per second. In the vertical direction, because it's opposite of the 25-degree angle, we're going to want to use sine as opposed to cosine, and then we're going to use the sine of 25 degrees multiplied by that 10, and then we have a vertical component of 4.23. Now, because our vector is pointed downwards, I want to make sure I put a negative in there. So when I put the initial velocity in here, a key component is to make sure it's negative 4.23 meters per second. Now, from there, we know a couple things. We know the acceleration due to gravity of anything in free fall motion is negative 9.8 meters per second squared. And then one more thing in addition to that, which I forgot to include in my original drawing, is that the object is dropped off of a 5-meter platform. So our delta y is going to be negative 5 meters because the object is displaced 5 meters from its original position, or negative 5, excuse me, because it's downwards. Now, with those different values, we can go ahead and plug them in to this equation right over here, and that's going to allow us to find our time. So let's go ahead and do that. All right, with our setup here, we plugged in the delta y equals VIT plus 1/2 AT squared. I just added the 5 to both sides, which moved it over here. And then I multiplied the 1/2 times the negative 9.8 to get this coefficient of negative 4.9 in front of the t squared. And then this negative 4.23 coefficient has remained the same. So from there, you can use the quadratic formula, or you can also go ahead and graph this and then find the two intersection points of where your graph hits your x-axis. You're going to get two values, which is 0.67 or negative 1.53. Clearly, our time is not going to be a negative value, so we know it's going to be the 0.67 seconds. Now we just have one more step to finish things off. We found our total time. Now we want to go ahead and find our delta x. We can now use our constant velocity formula over here, but I'm going to cross multiply this t up and over. So v times t equals delta x. And our velocity is right over here. It's 9.06 times our time of 0.67. And then that gives us our final delta x value of 6.07 meters. So when you're solving for a problem like this that has a downward angle, one of the key things is make sure you find your Vx and your Vy, but then your Vy is going to be negative, which means you're going to want to put a negative symbol in front of your Vi. If it was something that was angled upwards at 25 degrees, the problem would actually be very, very similar, except this would be positive, which would make this positive over here. And it turns out that if you were on an upward angle of 25 degrees, this would be your time, because when you would plug it into the quadratic, your answers would be 1.53 and negative 0.67, and then this would end up being your time. You'd have a greater time and a greater delta x at the end. Okay, so for this one, we shrunk our time down because we directed our object down towards the ground, so it's going to hit the ground faster, shrink our time down, and then in the end, shrink our delta x as well. But anyways, as our final step, we're going to want to make sure we take our velocity in the horizontal direction, combine it with our time, find the product, and then that gave us our final answer of 6.07 meters. I hope that was helpful to you. Thank you for watching and listening.